Hi everyone, good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Evening, everyone.
Yeah. So, in the interest of time, shall we begin? Okay. Um, so today we'll be taking a session on utility values, prims, proms, PROs, right? And as it is said in the industry, and we will cover measurement of utility value, PROs, and also followed by AI in HEOR. Okay. So I'll just share my screen. I'll switch off my video, and let me know once you are able to see the same. Okay. Okay.
Yes, it's visible.
It's visible, right? So let me go. Akansha, all yours, okay? I'll make it full screen.
Thank you. Thank you, Richa. Hi, everyone. Hope you have had a good time learning HEOR. Let's continue understanding now new concepts about what health utility measurements are, what is PRO are, what is PRO basically. And then I'll take these two sessions and then it will be followed by AI in Healthier, which will be taken by Dr. Richa. Okay, move on, please, to next slide. So we have divided our session in these four major topics. First is measuring. So I would first explain you about what are PROs and prompts, and then we'll discuss about the measuring, like measuring how actually you measure health related quality of life. These two are basically interrelated. Then how do you map and valuation? How do you map and value your utility values? And then it would be last would be introduction to AI. Next slide, please, Richa. Okay, starting with what PROs and prompts patient PROs and prompts are. So basically, these are patient reported outcomes. PRO stand for patient reported outcomes, and prompts is the measuring tools of those outcomes. So patient reported outcome measures is prompts. Now, what exactly PROs are? So anything coming directly from patient about their health condition without being interpreted by a specialist, a physician, is PRO. Okay, something coming directly unfiltered from patient is patient reported outcomes. And the tools, the standardized tools, the instruments which are used to collect those types of data are prompts, patient reported outcome measures. Okay, now together these two things provide the patient perspective, overall patient outlook on his symptoms, his functionality, about his perception about his quality of life, which is essential to do economic evaluations, and we do use these types of outcomes in our economic evaluations, and when we are actually submitting to health regulatory authorities, we do provide these types of data information as well in terms of humanistic or societal burden of the disease and how the treatment is actually helping or not helping in reducing that burden. Okay. So next slide, please, Richa. Why is it important? Why do you want to know about patient-reported outcomes? So, as you can see, there are four different uses or benefits of patient-reported outcomes. First is it actually captures the real-world impact of the disease or treatment beyond just clinical metrics. Okay, beyond just what is being reported by the specialist or physicians, it actually helps you to capture the real world impact of a disease, much more than the objective symptoms, the subjective symptoms which patient actually feels after getting a treatment or after having a disease. Okay. Then second thing is it provide inputs for health related quality of life and utility assessment, utility estimation. Basically, in health economic evaluations, you do need these types of inputs with respect to the humanistic burden, with respect to the health, the quality of life, and it is then used to estimate the utility values, which are then used in the cost effectiveness analysis, which we have talked about in our previous sections. So when we are breaking the cost effective analysis, as I have already told you, there are two parts to it. One is the cost and other is the effectiveness. So the effectiveness measure comes from here. Okay, the quality of life segment, the quality of life part of it comes from here. Then it also supports the value demonstration. Value in terms of, like, as I told you, in regulatory submissions you do provide information about the burden of, like, how the treatment, new treatment for which you are doing the submission, regulatory submission, how it is actually providing the value. Is it just providing the symptomatic relief, or is it actually increasing the quality of life? Is it actually increasing the value of the life? So in that case, it actually helps you to provide evidence. It supports the value demonstration for payers, for regulators, and HTA agencies basically. Then the last one is it helps you to inform shared decision making and patient centered outcome, patient centered care programs. So when you talk about patient centered programs, it will be only implemented if you know the patient side of the disease, like, right, just apart from what is clinically reported, the how patient thinks about it, how patient perceives the treatment, how much he is able to adhere to the treatment, what are the barriers, what are the gaps, all these things comes under patient reported outcomes. Okay, and it is important to know uh, all these aspects, because once these are known, then only we'll be able to provide a program, a care, a solution to, which is more patient centered, right? So it's important to inform shared decision making, and it helps you to, you know, provide patient centered uh, approach towards the care. Next slide, please, Richa. Now, what are different types? We have understood what PROs are, why it is important to know, and then now I'll tell you about what are different types of PROs. So, broadly, there are mainly four types of PROs. One is symptom based patient reported outcomes, which can be like what patient exactly tell: pain, fatigue, nausea, the symptoms, what patient feels. These are the symptom based PROs. Second is functional status PROs. How physically patient is feeling, how emotionally patient is feeling, or how socially, what are social limitations comes along with the treatment or along with the disease. Okay, so functional status of the patient. Then you have health related quality of life PROs, which actually includes overall well-being of the patient, like how patient perceive his own quality of life, uh, which include different dimensions to it. Okay, and then we have treatment satisfaction. So treatment satisfaction, how patient is actually feeling after taking the treatment, as I already told you, like how much patient is able to adhere to the treatment, what are the side effects, how much he was able to tolerate the treatment. These all things come under treatment satisfaction related PROs, right? Next slide, please, Richa. Now, how do you measure these PROs? There are different tools available to actually capture this type of data directly from the patients. And there are broadly two types of measurement tools. One are very generic. Okay, other are very disease specific, very condition specific. These are now generic ones are applicable across diseases and across different populations, be it Asian, be it American, be it Australian. You can apply these generic tools to all populations and to different disease conditions like diabetes. You can compare. You can actually using these tools. You can compare diabetes uh, with the other disease. Okay, so these are generic tools. It helps you facilitate comparison between conditions and interventions. You can compare one intervention with the other. For example, how do you do that? So you have questionnaire. These tools are basically the list of questions. Okay, and if you want to compare two disease conditions or let's say two treatments for diabetes, let's say, so you will apply the same questionnaire to one patient who's actually taking one type of diabetes drug, and the same questionnaire you'll apply to a person who's taking other type of the other and diabetic drug. Okay, and then the score that is generated out of the two questionnaires, you can actually compare and see which is providing you better value, which the condition of which patient is more worse or whose condition is better, and then you can actually compare. Okay, generic tools. The example of generic tools are EQ5D, SF36, World Health Organization Quality of Life tool. These are freely available tools online. If you want to read about it, I would suggest go to their websites and read about it. They are very self. They have a good, toolkit available. They have a good explanation available, and you can actually apply these into your practice with your research, maybe if you want to. Then the second ones are disease specific prompts. These are not generic. So you can't compare your diabetes with cancer. No. These are very specific to disease conditions, tailored specifically to capture the these condition specific symptoms or impact. For example, you have EQRDC, QC30, that is for oncology, for cancer related patients. Then you have AQLQ, which is for asthma, for respiratory diseases. Then KDQOL, that is for kidney disease related quality of life questionnaires. So these are questionnaires are tailored specific to those health conditions, and from these you get information related to that particular disease, and it is specific to the particular type of conditions also, not generic. Okay, next slide, please, Richa. Now we have understood what patient reported outcomes are and how to measure those different tools. Within those patient reported outcomes, you have health related quality of life. It's also a type of uh, patient reported outcome. As I was showing you that chart, in that you had health related outcome, health related quality of life as a separate patient reported outcome. Now what it is, it refers to patient's own perceive, like his own uh, opinion about his physical and mental health over time. Okay, this is health related quality of life. How he perceives his overall functional, physical, and mental health over time. It measures how disease and treatment affect his daily life or his functioning and overall well being. So, it's not the quality of life, health related quality of life is patient's perception about his own health. How do I feel about my health? This is all about health related quality of life. Why it's important to know what are its advantages? It captures patients' experience, not just clinical outcomes like survival. Okay, it's not just telling you that like I am living this to this year, like I'm survive the yeah X person who had cancer survived for this many years. It's not just about survival. How well? what was his overall experience during that survival, during that journey. It actually helps you to capture that. Helps in evaluating new treatments, not just whether they extend life, but whether they actually improve it. Okay, any new treatment, let's say an oncology treatment is coming, it's not only about survival, as we have already told in previous sessions also, that now we don't only think about the treatment which is in extending your life. It's about how improved your life is after taking that treatment. If it's just increasing the survival, if it's just increasing life, if it is just adding life to your just adding years to your life, it's not important. It's important how well you are living those additional years in your life. That is what it helps you to evaluate. Then it is used in cost effectiveness models to calculate your qualities. So health related quality of life actually helps you to calculate qualities, which goes into your economic models as a parameter, effectiveness parameter, right? Next slide, please. Now, these are two examples which I have shown, EQ5T, 3L, and 5L. So these are different levels. 3L has three categories of responses. 5L has five category of responses. This is one tool, just one snapshot, a snapshot of this tool. So here you can see that you have different different domains: mobility, self-care, usual activity, pain. These are questionnaires which are administered to patient, and they will tell how much mobility he has. Based on these options, he will take one. Similarly, how he perceives his own self-care, how he perceives his usual activities, how he perceives his pain or discomfort, how anxious or depressed he feels. Based on their responses, uh, the a score is provided to them, a number is allotted, and then based on that, uh, health related quality of life utility value is derived. Okay, next slide, please. Now comes the utility value. What is that utility value? I told you that those questionnaires helps you derive utility value. Now, utility, it is a measure it is a way to quantify health related quality of life. It is basically a number which ranges between 0 to 1, and it represents quality of life in a particular health state, right? If a patient is having diabetes and you administer that EQ5D to him, we can say that his quality of life, whatever the after doing his assessment, whatever number comes out, we can say that this diabetic patient has this quality of life, this much utility value. His his quality of life is this much, based on that number, that utility value. Okay, it is used to quantify health related quality of life so that different health states can be compared objectively. As I mentioned that if you within diabetes, you have pre-diabetic, you have no non-diabetic, you have pre-diabetic, and you have diabetes, and then you have advanced conditions of diabetes, right? So each of these state will is different, the severity is different. Non-diabetic will not have any problem, but pre-diabetic will might have some discomfort in his life, or maybe his how he perceive his health would be different from non-diabetic. Similarly, the one who has diabetes would perceive his health differently from pre-diabetic and non-diabetic, right? And the ones who have advanced disease, they would further differently perceive their own health. So that's why we can actually compare the different health states with each other using these utility values. So actually this way we can actually compare different health state, which is more severe one, which is uh, less severe. How it works, how utility works. So as I told you, this is a number between 0 to 1. 1 stands for perfect health, 0 stands for death. There are, you will find sometime in economic evaluations or at places, there are negative utility values also, values less than 0. It means that the situation of the patient is even worse than death, like extreme pain or discomfort or complete immobility if patient has in case of like cancer, or maybe in uh, a situation where he is completely unresponsive. So those are situations where he might have negative values also. Okay. Now, what are sources of utility values? Again, as I told you, these values come from the surveys, patient reported outcome measuring tools like EQ5D, SFD, or disease specific tools can also be used. Then you get these type of data from published literature. You don't have to do it all. You don't have to administer these questionnaires every time. You first search for published sources if it is available. Uh, then use the published source first. Otherwise, you can do the patient survey as well. Then trial data. Sometimes clinical trial also report these utility values. Sometimes and even if it is not available, then last option is you ask experts in the field about this, and how you actually ask them and take their opinion about the utilities. Okay, so here in the table on the right, you can see we have provided an example of different utility values for different health states. Like for perfect health, it would be 1. For mild asthma, it is zero point 0.9. The situation is not severe, so mild asthma, zero point 0.9. If patient is having arthritis, so in arthritis, you will find patient is more immobile, right? He will have difficulty in doing his daily tasks, and then his utility value is zero point 0.7. In severe stroke patients who is bedridden, the utility value is zero point 0.3. Patient who is having uncontrolled cancer pain, here utility value is zero point 0.1. Persistent vegetative state, like patient is in coma, the utility value is minus 10. Minus 0.10, 0.1. So this is just an example to give you an overview about how utility values are uh, uh, like looks like basically. Okay, next slide please, Rita. Now we have understood about what utility values are. Now, mapping and valuation of utilities in health, HEOR. Uh, when direct utility values are not available from published sources, we take help of mapping techniques. It helps you to predict values from patient reported outcomes or clinical trials. Like other, if there is other patient reported outcomes or trials available where they have captured patient reported outcomes, so we can leverage those, and using mapping we can actually predict or calculate the utility values. Mapping is development and use of a model or algorithm basically to predict utility values using data on other indicators or measures of health. Like for you don't have a utility value for COPD example, but you have it for asthma. So you can develop a model or algorithm to actually use the PROs of asthma to simulate and you map and actually calculate the values for COPD. Okay. Clinical trials often collect non-preference based PROs. Like as I told you, for cancer, there are specific tools available. They don't use generic tools measuring PR prompts. They don't use generic prompts to to report the patient reported outcomes. So instead of direct, they don't since they don't report direct preference based PROs. So Mapping can actually help you to derive utility values in such cases where preference based PROs are not being used. Okay, and it helps you to estimate utility values compatible to your economic evaluations or compatible to your studies where you want to actually see the humanistic burden. Okay, so it's basically modeling. It's based on the algorithms where mapping is done. Next slide, please, Rita. Next comes valuation. Mapping is different thing. Mapping, when you have non-preference based PROs available and you have to derive utility values out of it. Valuation is when you want to assign societal preference weight to health states, which are described by instrument like your generic tools. Okay, so mapping is used for your disease specific tools, while valuation is used for your generic tools. So you might ask what so you might ask what societal preference weights are. Okay, when you're using these general tools, generic tools like EQ5D, which can be used over for different populations and different patient populations or different countries. So societal preference weight basically refers to values which are assigned to different health states based on how population or how a society perceive those health states to be. See, let's say one example, malaria. Let's say malaria. Within India or globally, malaria might be a concern for a particular country. On on the other hand, it might not be very much concerning for maybe European countries, maybe or it might be more concerning for countries where malaria is endemic, right? So basically, a disease has its distribution different all across the globe. It's not same everywhere. So the preference of the society will also differ based on the prevalence of that disease, right? So societal preference weight actually helps you to uh, provide a societal per, perspective of that disease. So valuation helps you to assign that weight, societal weight to the health state to give it more realistic, more geographical perspective on that health state, I would say. Asthma might be more concerning to India, or if we talk about different months, it might be more concerning during certain time point than other, right? So based on that, societal preference weights differ, and it's not just about individual point of view, it's about a societal, how society overall view that health state, and based on that, these values weights are assigned. Now, how these weights are basically assigned? There are different techniques to it. One is time trade-off, then we have standard gamble and visual analog scale. Okay, now time trade-off is the most common one. In this, what happens is patients are being, so these are all societal. So you are asking questions to the population, okay, and patient people are asked that are you ready to trade off your additional lifespan for better quality of life? I'll explain you more in next slide. But just understand, if you're living 20 years with a disease condition, you're giving two options. You are given two options. 1 year that you live additional 20 years at with diabetes, let's say. And other option is you live 10 years, not 20 years. In place of 20 years, you live 10 years, but in a perfect state of health. Which one would you like to choose? These type of questions are asked to the society, and then their choices are being taken, and then societal preference weight is being derived. Utility value is basically derived. Then the other method is standard gamble method. In standard gamble, two choices are given to society, to people, and it is blinded. People don't know which option has what value, and then they are asked to choose. So choice under uncertainty, and then whatever they choose, based on that value is derived. Then third one is visual analog scale. Okay, in this you do the direct scaling. So basically, uh, direct rating of hair state. How do you do that? So uh, uh, people are provided with a scale of 0 to 100, and they would be asked questions like uh, how do you feel about this particular health state? Let's say asthma, severe asthma, mild, moderate, severe asthma. How do you rate how would you rate your situation if a person is asthmatic and he's being asked, how would you rate your health state between 0 to 100? And a person says, okay, I rate myself 50, 60, 70. And then overall, after all the responses from the patient, it is collated, and then utility value is derived. Okay, so these are three different techniques where you are actually you are deriving the utility values from the population based on their preferences. Okay, uh, so each country each country develop their own tariffs or values set based on population preferences. So there are chances that you will find that the utility value for asthma, mild asthma, is different for UK and different for US and different for India. It's because it's based on their valuation, based on their own social preference weights. Okay. And these value sets are applied to instrument responses to compute. These are basically used to calculate the utility scores. Next slide, please, Rucha. Just to give you more insights about time trade-off. The other two are very simple. Time trade-off is something which takes time. It's more to understand. So I have explained, given one slide here on time trade-off. So it's a choice-based. All those three were choice-based method. Time trade-off is also a choice-based method of knowing the health state utility, which reflects the length of remaining life expectancy that a person might be prepared to trade off in order to avoid remaining in sub-perfect health. What example I gave you? I gave you two options. I asked you have two options. Either choose 10 years of perfect health, 10 years of life with perfect health state, and the other one is 20 years of life but with a disease condition. Okay. So respondent chooses between the two, living T number of years in a certain health state or living in a shorter time X years in perfect health state. So how utility value is derived? The formula is X by T, where X stands for the shorter duration for which patient can live. Like in our case, it was 10 years. In our example, it was 10 years. And uh, divided by the number of years he could have lived. 20 years he could have lived. Okay, 10 divided by 20, right? And this way you calculate your utility value. Another example is given here. If a person prefers 6 years in perfect health over 10 years with chronic pain, the utility value would be 6 years in perfect health divided by 10 years in chronic pain. the utility value will be 0.6. Okay, understood? So patient is trading off his additional years which he might live with a health condition. He has traded off those years to live in a perfect state of health. This is time trade-off method basically, and these are very common to use to actually do the valuation when you are calculating any country specific utility values. Next slide, please, Rita. Now, once we know our utility values, we have gathered our utility values maybe from published source. If we don't have it from published source, we have used the prompts and derived the values. Now we need to actually calculate QALYs. Okay, you have the utility value. So QALY is a measure which helps you to quantify the health benefits of a medical intervention or prevention program, combining length of life and quality of life into single metric. So it's basically an arithmetic product, if we say in mathematical language. So it's a product of quantity of life, like number of years lived, multiplied with the quality of life, the utility value, which we have talked about in our previous slides, right? The product of these two gives you quality adjusted life years. Why is it important to know? It allows decision makers to compare treatments because as we have seen in our previous sessions that we want to compare different interventions, seeing how much quality they are bringing with the treatment, and to compare that if we have a single metric like quality, it is easier for for people to uh, to actually compare, and not just it so again the question is it does uh, the question is not just about does it make people live longer, but also about are they living better with the treatment. This is the basic uh, rationale behind knowing the qualities. Then it is used in cost effectiveness analysis to calculate the incremental cost effectiveness ratio, which we have talked about, where you have cost difference in the numerator and quality difference in the denominator. Next slide, please. Basic example of calculating qualities. So you have this is the arithmetic product as I've told you. So here let's see a few examples. Perfect health state. If a person is living in a state of perfect health for 1 year, and the utility value for perfect health is 1. So the qualities for that health state would be 1 multiplied by 1, which is 1. So patient has 1 quality. If the person is living for 1 year in chronic disease, and for chronic disease, the utility value given here is 0.6. You multiply these two and the total quality would be 0.6, right? Then next is severe disability. If the person is living for 2 years with severe disability and the utility value is zero point 0.4, the quality would be zero point 0.2 into zero point 0.4, which is 0.8. Hope this is clear. This is understandable basic maths, nothing fancy. Okay. Last is moderate health state. 5 years living for 5 years with zero point 0.7 utility value. The quality would be 3.5. So this way you can actually calculate quality for any health state if you want to have. Okay. And for calculating utility values, you have to get back and see your different sources. If you don't have sources, then you have to actually, if you want to do it, if you want to do country specific valuation or mapping, you can do that also. Right? Next slide, please, Raja. This is one exercise. Maybe we'll give it for the assessment. Next slide, please. Okay. It's done from my side. Over to you, Rita.
Thanks, Akansha. Yes, as you rightly said, we can give that as an assignment, right? The
Yes.
exercise. Okay. Hi, everyone. Good evening. Let's talk about artificial intelligence. So, in my upcoming slides, I will take up some of the basic definitions, how AI is being used in HEOR and life science industry, and there are various courses available. What to learn, how to learn, is it useful or not? That I can share. Also, being in Singapore, I get an opportunity to go to a lot of conferences, webinars, workshops, educational sessions where they teach about agentic AI, generative AI. So a majority of the things by now I have seen hands on, like it exists. Okay. The coding that goes behind it, basically it is done on Python. How it is done, how the prompts are generated, what are large language models, how various industries are using them. Right. So with this kind of exposure, I will be able to share certain examples with you, which you can correlate. Okay. So Alan Turing, who is he? He is considered as the father of AI. AI has been there long back. Okay, with different terminologies, with different things. AI is not something very new. It is not something which has come today. Very interestingly, I was at a conference today of technology and innovation, and the conference had a lot of bots in them, robots like that we see in movies and other things. And they had a tagline, and I've posted the picture on Facebook and Insta, also on my account, and LinkedIn as well, if you can go and see. They were claiming that bots for houses and bots for office space. And I'm like, houses, like, is it still possible? Like, I mean, we have a vacuum cleaner at home, which is in shape of a bot, right? Small bot, and those kinds of things you see in commercial spaces. But they said there's still a perfect bot for household is still to be, come up, right? But what we are trying to say that AI has been there since pretty long. A computer would deserve to be called intelligent if it could deceive a human into believing that it was human. Right. Agentic AI is doing these nowadays. Okay. So many of the customer care that you are calling today, they are all AIs. Right. They are all based on agentic AI. There is no majority of them do not have any humans behind it. They are the generative AI voices that you hear. Right. Now let's look at some of the terminologies or definitions. And as aspiring professional or working professionals, you should be familiar with these ones. Okay. So there is a broader umbrella called artificial intelligence, right? What it does, it helps us in decision making, pattern recognition, language understanding, predictive analytics, robotics, and automation. Guys, there might be certain slides which you must be thinking that I am reading out. Okay. But for some, there is no other way of explaining it. I will give anecdotes and example as and when required, but please bear with me. There might be certain slides which you will find me reading through, because that is the best way to understand. Okay. So now coming to what is generative AI. It is a type of AI that can create new content like text, images, audio, video, or code. And the examples of this generative AI is Chat GPT, Copilot, and many others, right? So, as we were talking about, AI is a broader umbrella. If you see, there is ML, machine learning, there is deep learning, natural language processing. Okay. And in this, conversational AI and large language overlap using these techniques. By the way, in today's conference, I also saw the quantum computer, the hardware that goes behind the quantum mechanics. It was very fascinating to see. And nowadays, the concept of quantum mechanics is coming everywhere. Maybe in our one of the upcoming sessions, we might be able to take that. But I'm still learning that, and I like to learn new things. This is what I want to encourage everyone. So my aim is in another 2 to 3 months I should be able to take a session on quantum mechanics as well. Right. Now, what are large language models? They are the foundational models within Gen AI. They are trained on massive text based data sets to generate human like language. The important thing is they are trained on massive data sets. Okay. So a lot of companies nowadays have their own proprietary large language models. So ChatGPT is a perfect example of large language model. Okay, right. So, do you think all these companies these days are making their own large language model? All the consulting company, pharma companies, they for privacy and the risk of data sharing, they want to have their own LLMs. Okay, rather than having their employee using ChatGPT. So what they do is they buy a particular part of large language model and make it enterprise specific, right? In case they have to create their own large language model, it will come at a lot of cost, and lot of time will be given on, because it requires training on large data sets. So majority of them, what they do is they buy existing large language models, and then they restrict the usability in their own organization. So a lot of companies, they deploy the large language models on the cloud platforms of these company. The companies who deploy these platforms, they do not have any access to their data. They are just kind of a service provider for us, where they provide the large language models, and also the maintenance and everything lies on the owner. So this becomes a very hassle free and privacy driven environment for some of the enterprises. Okay, so chatbots. So this is how the evolution of agentic AI is there. Now let's understand. So we have seen what is AI, the broader umbrella in which there lies something called as the generative AI. We saw that. Now with the evolution, there is another terminology called agentic AI, which thrives on self-learning, proactivity, and collaboration, enabling adaptive context aware systems which act autonomously. It has the ability to take the decisions and adapts learning and reasoning. These customer care voices that you hear, I was telling, they are on agentic AI. They are trained on different languages as well. So if in between of English I start speaking in Hindi, it adapts itself and starts speaking in the same language that I am speaking. And I have tested them at many conferences myself also. Okay. A very interesting app I came for agentic AI in Singapore is, I'll give you the example of that. Many of our parents are live in our hometowns, right? uh, we are the professionals who are working or studying in different cities. After COVID, there was some, for some time people were working from home or something, but now people are being asked to come back to office. Same goes in Singapore. Okay, so what happens is elderly stay alone. So the agentic AI app, it calls the parents every morning, ask about the well-being, right? If the elderly says, no, I'm not feeling well, the agentic AI reminds them about the medication. Let's like, your medicine is in the red bottle, did you take that? All the data has been fed, but depending on the answer of the elderly, it modulates the question. It even asks the elderly, do you want us to call ambulance for yourself? And if the elderly does not pick up phone, let's say after 3 try or so, the call gives out to the primary caregiver whose number has been registered. Right. This is how these apps are working these days. This demo I have seen live. That's why I can share this. Now, why everyone is talking about agentic AI? How it can help us. So it helps in autonomy and takes a lot of decisions. It adapts and learn. I have given you the example of the language. It is driven by specific goals and objective, and instead of simply following rules, it can make independent contextual decisions based on information available to them. Now, for making agentic AI or Gen AI, there is coding required, and the codes are written in Python. Right. So, if you ask me, what language shall we use or learn if we want to make our career in such kind of things, I would say learn Python with AI. Yes. If you can, please do. Kind of a schematic approach. Okay, so it works on multi-modality models, agentic AI, right? So user requests, I want to go shopping, or can you find the best hair salon, or can you book an appointment for me? Okay, then agentic AI, imagine this as an agent. It's all Python coding, right? But imagine it's an agent which is based on perception, cognition, and action. Now it is intelligent that it can take commands from audio, text, sensors, and visual. It uh, it then imbibes it in the memory, forms a knowledge base, and helps in decision making, and then it takes the action. Right. Okay. Looks fascinating, sounds fascinating, but yes, it is working. Right. So, AI agent, the user gives a command to the AI agent. It is based on the pre trained data set from where it imbibes the knowledge, I would say. And these are in the form of large language models. And then it takes the decision. Now, quickly see the difference between Gen AI and agentic AI. So let's move towards the right side first. Let's see what are the characteristics of Gen AI. Automation. The process of automating content creation tasks, generation of novel and unexpected content, helps in pattern recognition. It is driven by data, and the primary function of Gen AI is to produce new content based on the learnings given to the large language model. Now, what are the characteristics of agentic AI? It improves performance, right? It takes action. It is very much independent, helps in decision making, perception, perceiving the environment through sensors. As I have shown in the previous slide, it works on multimodality system where it take perception through audio, visual, sensors, text, everything. It is goal oriented and it is autonomous, right? Can we leave everything to Gen AI or agentic AI? Answer is no. We will learn in the subsequent slides how. Right. So quickly, Gen AI, you give the data input, model is trained, content is generated, evaluated, and refinement is done. Agentic AI perceives environment from multimodal sensory systems, analyzes the decision, it makes the decision, executes also, but it keeps on learning from the result. If you ask the agentic AI to book your appointment for a salon, it will do so. Right. There's a very interesting video on this by Sundar Pichai on YouTube. You can see that. Right. It's very funny, very entertaining. Okay, now what is the functionality of or applications of agentic AI versus Gen AI? So Gen AI, it's used for image generation, text generation, audio, video generation, and drug discovery. Right. I was at a Google roundtable in one of the conferences, I think 2 months back, where they were showing one of the advertisement, which is generated entirely by AI. Right. How they do so? They take the picture of the model on, and based on that, they create the entire ad. And they've shown those ads. They were of coffee, they were of cars, and it was very fascinating to see that. Okay, now applications of Gen AI, robotics, amazing they are, so again, I'll give you one example of Gen AI in from one of the conferences. As I said, being in Singapore, it gives me an advantage of attending a lot of conferences. Tomorrow also I'm attending one of the conference on robotics and healthcare. I'll, if possible, I'll share the share what I learned in the next coming sessions. We still have 2 more weeks together, right? Okay, so there was one bot. That bot was acting as a cancer patient for whom the treatment was going on. So it had some pre-fed answers into it, right? So how do you feel? Does the hair go after the chemotherapy? Are you able to work? These were the standard questions. But then suddenly I asked one question which the owners later told me was not fed into the bot. It was, I asked the bot, are you the only bread earner for the family, or is there any financial support you have in the family to look after them? Okay, and the bot gave me the answer. Right. So the owners of the company said to me, like, the bot was not trained, right, for this answer. This answer was not pre-fed into the bot, but through agentic AI, it trained itself autonomously and it gave me the answer. Okay. Autonomous vehicles, I don't know. I still am apprehensive of sitting in a Tesla where no one is sitting on the driving seat. But I don't know. They act as your personal assistant, booking your appointments. You can play chess with them, right? And supply chain management, I see them day in and day out at various conferences, how they are taking the load. Okay. Um, one thing, many of the factories in China, they deploy bots. By that, for supply chain management, by that they are able to work 24/7, and they are able to operate at night in the dark as well, because the bots have a sensory visual imaging system through which they do not need light. They have it embedded in their systems. Okay, so that's how where the world is going. If you want, you can take a snapshot of this. There are certain prompt engineering and applications. You should know a few of them. These acronyms, right? So, like graph of thoughts. This is a technique, right? So, of giving the prompts. So, these are used in NMAs. Zero shot learning for estimation of cost effectiveness of new drugs. Program of thoughts. Uh, Update living HTAs. Tree of thought, simulate policy scenarios or branching patient decisions. Analog prompting, okay, adapt existing models or explain ISRs with relatable analogies. Least to most prompting, extract trial demographics or automate SLR summaries. Self consistency, explore alternative model conceptualization and select most robust. Algorithm of thoughts, um, automate budget impact or systematic review flow works. Chain of thought, build Markov model or define sequential treatment pathways. Reason and act, incrementally build models, adding treatment and cost data. Chain of logic, validate assumptions to ensure internal consistency in models. Skeleton of thoughts, draft value dossiers or outline early stage policy framework. Right. So to fully leverage LLMs in HEOR, mastering of these prompts is very important. There are various courses available on prompt engineering. Okay. And they are available on YouTube. Please try and learn. these are some of the large language model. These are some of them which you need to know. Chat GPT, GPT-4, Gemini, Claude, right? So Llama. Okay. So there are various LLMs which are available. Okay. Now, what is RAG? Okay, so we have learned what is large language model. Now, what is RAG? Okay, so if we give a command on large language model, it will give you the answer, but it will hallucinate a lot. What do we mean by hallucination? Let's say if I'm building a proposal and I ask what should be the price for this project, it gives me a very vague answer at times, says $100,000 to 1 million, anywhere it can be. That doesn't suffice my purpose. Right. So we put something called as retrieval augmented generation. When I say put, which means we give a command by Python. Okay, it's a technique that enhances the capabilities of large language model by allowing them to access and incorporate information from external knowledge sources. Graphically, if you want to see, I will show. Sorry, it's a bit hazy, but this was the best picture I could get. Right. So, in an isolated large language model, you give the input, your pre trained large language model gives the output, which can be very vague. Now, let's say when you integrate any RAG into it, this is the input you give, relevant query, right? Now it has a searching vector database. So it is a kind of a filter which you can restrict to trial data. Basically, you are putting kind of a limitation or selection that this and this I want. RWE, systematic review, HT or PROs. This is that you want. This refined query goes to LLM and you get an output. This is the RAG architecture. This is all in the form of Python coding. Simple example, Netflix, right? When you search, there's a search bar button in on Netflix, right? When you search, okay, it majorly gives you the specified things that you have asked for. They have put RAG in it. Otherwise, it will hallucinate and it will be all over the place. Okay. Uh, we have seen this. Okay. Gen AI, RAG. Okay. This is what I have told you, user interface, large language model. So user interface. So first you give a prompt, then you retrieve it from model, prompt plus context, large language model, and the response is generated. This slide we have seen more or less, right? So let's see RAG now, how it is used for streamlining the HEOR applications, right? So is you see RAG or graphical form of RAG is used here, right? So processing large data sets like systematic review, multi-country HTA submission, meta-analysis exceeding the LLM's memory capacity. Sometimes you get so much abstracts to screen that it is not possible. Then you put RAG, you make the command restricted. Transparency and traceability is critical. Okay, referencing retrieved documents. When I use chat gpt many a times, we have seen that the references are not authenticated. You have to go back and you have to check. Managing data sets, large data sets, managing multi-level variables where you have to deal with so many variables at single point in time, can be disease progression states, resource utilization, treatment pathways, etc. Conducting meta-analysis, managing data sets like claims data, clinical trials, PROs, verifying outputs from systematic reviews for feasibility, analyzing pros or health state utilities, right? Modeling multidimensional outcomes, processing cost effectiveness model. Can we use RAG and give it to the client directly? Answer is no. We will look into it as I have promised in the upcoming slide. How it is used in, by the way, for AI, I saw a very good example in today's conference. They were making monoclonal antibodies by using AI, which can enhance the process and just complete this in a number of few days. Okay. Also, in Singapore, I saw the launch of one of the data sets, which was for identifying the new potential molecules, right? And it reduces the preclinical stage, and the project was funded by one of the universities of Singapore by NVIDIA. Hewlett Packard provided the hardware, and one of the IP companies had protected their intellectual property rights. So these are the things which are upcoming. LLMs, they help in accelerating drug delivery, optimization of clinical trials, enhancing the modeling, include improving medical writing and communication, decision making, and automating a lot of tasks. Further, can help in automation of meta-analysis, any personalized medication, economic burden studies. But there are challenges: data quality, bias, data needs to be trained, it hallucinates a lot, and you cannot, and there is a lot of issues in traceability and retrieval of the same results, which will not be possible. Why? Because all of us give different types of prompts. Let's say if I have a research question, I will write it in a different way, Akansha will write it in a different way, you all will write in different ways, until unless, of course, a script is given to all of us. We have discussed this, hallucinations in AI. Just two terminologies I will read out to you. There is factuality hallucination and faithfulness hallucination. What is factuality hallucination? It means LLM's output either contradicts real world information or is unverifiable against established real world knowledge. Okay, it occurs when LLM incorrectly cites outdated clinical trial data or invents cost estimates that do not align with actual healthcare costs. Faithfulness, when LLM's output either deviates from users' directive or is unfaithful to the provided contextual information or exhibits logical contradiction. It can arise when LLMs fail to adhere to specific model parameters. That's like, for example, transitioning between health states and Markov model in a manner which is inconsistent with clinical guidelines. Very important concept, HITL, human in the loop. This is what I promised. For every AI that we use in conducting our work, there has to be human in the loop, has to be QC'd, has to be, idea needs to be generated by the human. The AI acts on it, but it needs to be QC'd. See if something goes wrong. You cannot tell the client AI did it, punish the agentic AI. No, that doesn't happen. Okay, right? That doesn't happen. Okay, right? So human in the loop is very important. Gen AI can support with live literature reviews by regular processing of search strategies predefined by human experts. Okay, what happens in human in the loop paradigm? AI takes the lead in processing the tasks while humans stay in the loop to set goals, validate, refine, and do the QC. Okay, AI can be used to perform extraction from text, graphs, tables, and documents. Humans can validate context and completeness of the review proposed by AI and provide intermediate and final approvals, because we deal with human lives, we deal with human data here. It needs to be QC'd and verified. Okay, so these are the use cases, right? Active learning, AI-led data selection and validate uh, AL. Active learning is a machine learning paradigm instead of this. This we have discussed, the role of AI and the human role. We can skip. Now this one, human in the loop. See, uh, okay, so if you do a task, manual, automated, or human in the loop, cost reduction, okay, automated, high cost, but HITL, it lies in the medium range. Accuracy, it doesn't say entire complete accuracy, but still, yeah, it's there, it's 90 high, it's 96 to 99, 90 to 98 manual. Complete automated, it's low, but if there is human in the loop, it increases. Turnaround time, slow, fast. Scalability, none, high, and medium. Technology, people are there, AI, and it's a combination of AI and people. Risk of errors can be high, medium, and low. How, let's see diagrammatically, because I love diagrams. I used to make them a lot in my pharmacy days as well, right? My entire answer sheet was filled with diagram, and I'll say, like, I'm masters in pharmacy, so Rang and Dale ke jitne diagrams hote the na, all of them were in my pharmacology paper. So you take input raw sheet, you define the outputs, there's a supervisor, you make corrections, use the AI model, and it is processed. Okay, the supervisor is the human in the loop. Okay, okay. Now, AI in the loop. As we have HITL, you have AITL also. Now, what is the meaning of AITL? Human take the lead in carrying out the tasks, while AI supports the drafting, validating, and interim decision making. AI handles routine or computationally intensive tasks, while humans focus on core conceptualization, ethical consideration, and critical decision making. Okay, right. Okay. Huh. Now, this is very important. Now, this is hybrid intelligence framework for HEOR. So, which means at places where applicable, human in the loop, and at places where applicable, AI in the loop. Let's read this together. Active learning. Self learning where AI system with human annotation required only at critical data points. Interactive machine learning. Iterative feedback and refinement process between human and AI. Explainable AI. Methods to make AI techniques and process more comprehensive to humans. There is human in the loop. Now, AI in the loop. Machine learning. Human explicitly teaching and guiding the machine, and AI is in the loop. Validation and refinement. Human produces content and output, while AI is responsible for refinement and validation. Okay. Now, AI is rapidly transforming HEOR. Now, people come and ask me, Richa, can you tell us which software to use, which large language to use? See, there are pros and cons, opportunities and challenges with each and every one of them. A disclaimer, we do not endorse any of these, to each his or her own. But what the conclusion I would like to say is, human in the loop is very important. QC is very, very important. I consider AI as an enabler. I consider AI as a member of my team. AI will not take up your jobs, but people who do not use AI or accept AI, they might be as at a risk. I I met at a certain company at a conference where they have named AI, what was the name? I think Bella or something they called AI, right? So that team feels that it's a part of them. Okay, so for screening and extraction, there are various tools available. There are hybrid models, as we have seen. For managing large data sets, especially in real world evidence study, AI is used. In economic modeling, for streamlining, for various scenarios, for reducing the dependency on traditional models. Nowadays, clients are asking for models in Python and R Shiny with AI in it. Then for writing manuscripts and dossiers, but please avoid using derivative language. Okay, it can give you as a starting point, but not the finishing point. Finishing point is always the human. Right. Now, leveraging AI across HUR value chain, where it can be used. So, for various data sources, EHR, claim database, various. So, there is no single data source captures full patient journey, and you have to combine all these. It's not an easy task because all of them are written in different languages and require different kind of skill set. Okay, right. Then there is a processing layer which helps in data integration, cleaning, modeling analysis, and decision support, followed by various analytical models that are run on it, and the outcomes are perceived. Example, Amgen uses Repatha data to show fewer hospitalization and better adherence, highlighting real world value and supporting value based pricing. How it works: data intake, gather raw data from multiple sources, processing and cleaning of data, reporting, and then modeling, apply AI to analyze and predict the outcomes. Do you know, in a lot of imaging techniques also these days AI is used. I'm sure you must have heard companies like AstraZeneca, Pfizer, GSK, they are spending on AI for imaging techniques left, right, and center. When we say imaging techniques, X-rays, MRI scans, and sonography, where various non-invasive methods where you can predict the early detection and diagnosis of diseases. Right. So these slides have various examples for various data sets and how AI is changing the shape. It's a bit important. So let's read it together. For electronic health record, Takeda and Converge Health used insurance claims data with AI to predict treatment resistance in depression, supporting more targeted and cost effectiveness interventions. Claims data. Optum uses claims data with AI to identify high cost patients and predict hospital readmissions, helping payers manage those. Wearable devices. J&J partnered with Apple in Heartline study. It's a very famous study. Go and read about it. To analyze variable ECG data for early atrial fibrillation detection, aiming to reduce stroke risk and associated healthcare costs. Patient registries. Danish nationwide clinical register for patients with RA, known as DanBio, serves as a research register and a data source for rheumatological diseases. Right. Clinical trial databases. Flatiron's Health Oncology Database utilizes real world clinical data and AI to assess cancer treatment effectiveness and inform reimbursement and policy decision. Surveys. Pfizer utilized AI to analyze adverse event reports submitted by patients, enhancing PV and informing public health strategies. So, guys, this is a flavor that you can see AI is being used not only by pharma company but by the consulting companies, database companies to enhance the value. Now, that was the example of data sources. Let's see the AI processing layer. So, for data integration, Roche's clinical precision oncology program integrates clinical and real world data using AI to optimize oncology treatment pathways and improve patient outcomes. I know of the certain companies who are utilizing the real world data from these platforms to generate and help in patient support programs. How amazing and interesting it looks. Data cleaning. IQVIA uses AI driven data cleaning techniques to refine large scale healthcare data sets, improving the reliability of real world evidence used for decision making. Modeling. IBM Watson. So many studies they have done. IBM Watson Health used AI modeling to predict hospital readmission risks, helping healthcare providers reduce costs and improve care quality. Guys, take out some time during the day and just read. That then only you will gain knowledge in this area. Various analytical models for CEA. A pharmaceutical company used AI driven natural language processing to analyze extensive data on PD-1 inhibitors in oncology, identifying cost effective treatment patterns across subpopulations while reducing manual analysis time by 70% and improving predictive accuracy. Qualis, a study in UK evaluated cost effectiveness on AI based cognitive assessment tool for dementia screening. What they found, AI tool provided modest quality gains and cost savings compared to standard assessments, supporting its adoption in primary care and memory clinics. Adherence tracking, JMIR human factor study found that Medisafe app improved medication adherence and health outcomes in underserved chronic illness patients. And utility scoring from PROs, since we studied this today, a study evaluated the cost effectiveness of ePro tool in Canada. The ePro tool had higher costs and slightly fewer qualies, but could be cost effective if it improved qualies by more than 0.03, highlighting potential of AI enhanced PRO tools in informing healthcare decisions. So this is how AI is capturing various decisions as well. The last part, outcome measures. Clinical outcome, smart communications. digitally transform your patient registration and intake experience, reduce patient waiting time and staff burden, and slash operating expenses. Economic benefit: Optum's AI model predicted flu and COVID 19 outbreaks with up to 80% accuracy, enabling timely interventions and reduced hospitalization costs. Enhancing PRO: Roche Italia collaborated with Patch AI to develop Smart Health Companion, a digital platform that utilizes AI to engage oncology patients in self-reporting system and treatment adherence. So you see how much these companies are using AI in different forms and shapes for patient betterment and policy decision making. Okay, so it's enabling a lot of things, enhancing accuracy, personalizing the health economics, improving decision quality and timely decisions, cost reduction in healthcare. But yes, everything comes with a challenge. So comes the AI, ethical concerns and data privacy. If you are searching for any confidential thing or confidential information, use the paid version of the large language model. Can be algorithmic bias, as we say. You cannot trace the same information again, maybe because all of us give different prompts. Transparency and explainability. If any error occurs, you cannot tell client AI did it or punish the agent. Nothing such sort exists. Operability of healthcare data. A lot of unstructured data exists. Collating them becomes difficult. Regulatory considerations. Many of the HTA bodies and other regulatory bodies still do not approve AI to be used in various segments. Okay. Hmm. One quick example in in actual system how we are using this. Let's say for a particular pharma company comes to us and saying that we have so many publications in a year and we do not have the time to go through each one of them, right? So can you help us with a tool so that if we have a debrief with our boss, we just read everything in 15 minutes and present it to our respective bosses. So we do it in the form of agentic AI. We also use RAG in between to prevent hallucinations. And how the output the company wants it, either they get an email, a newsletter kind of a thing, or better still, they want a chatbot. You know those chatbots where you chat and you get the answer, to be integrated in their MS Teams. This is how it is working. Okay, simplifying the pharmacoeconomic models, right? How to explain the model, making it more user friendly, making the dashboards more interactive. So this is what most of the clients are asking. Right. Applications of AI in health technology assessment can help in quicker evidence generation, economic modeling, risk of bias, outcome prediction, stakeholder engagement. AI can help everywhere, but of course, there has to be a human in the loop. Some of the challenges you have to navigate, of course, data availability, transparency, ethical concerns, bias, generalizability, regulatory considerations, very important, and human oversight needs to be very, very important. Okay, this is the same as before. Okay, so now this is an example where you see AI assisted writers are also coming. So my suggestion here is you can use them as an enabler, as a starting point to understand things, but do not use that derivative kind of a language when giving your final product to the clients. Right, it's evolving in the medical writing. How? For any complex medical information, you can help in the synthesis of data, you can help in the understanding, but for writing the narratives and having your own value messages, write on your own. Okay, this we have done. Okay, Gen AI in dossier development. It improves the quality, enhances the efficiency, helps in summarizing the drafts, can help in conducting quick searches, help in preparing the objection handlers. But as I said, always have the QC done by the human. Okay, so couple of more case studies. Unlocking the future of pharma market with AI. how it is revolutionizing the industry. For TPP, product profile development, these models analyze real world data and historical analogs and predict the market viability and the patient needs. HTA and payer engagement strategy, natural language processing tools synthesize the HTA reports and payer documents to identify key drivers for reimbursement. Competitive landscape, AI tracks competitor launches, updates, market signals, evidence and HUI generation. We have seen this. Pricing and reimbursement optimization. AI uses multivariable modeling to stimulate price scenarios, competitor actions, and elasticity to recommend optimal launch prices. Also, it helps in post launch access monitoring. Right. And now, in clinical trial phases, also, let's say from phase 2 to phase 3, how AI helps, right? Gen AI for evidence synthesis and insight generation, automated literature review tool, value story drafting, narrative medical writing, this is used. Okay. And agentic AI, where it is used, where you have to see real time HTA intelligence, simulation engines for health economic models, and trial design and advisor agents. Suppose agents trained on payer and regulatory precedents can suggest endpoint adjustments, patient subgroups, and PROs that improve future access outcomes. Similarly, AI driven real world evidence planning. AI can identify patient population in large data sets for burden of illness studies, treatment pattern analysis, or external control arm construction. PRO instrument recommended tools, Gen models can suggest validated PRO tools based on disease area, payer relevance, and regional preferences. They also help in value optimization and early access strategy. Interactive global pricing simulators are available. What they do? AI powered tools enable scenario planning across value-based pricing ranges, supporting early price access trade-off decisions. AI agents for stakeholder mapping and sentiment analysis identify and engage with key peer influencers, researchers, and advocacy groups using AI curated intelligence from open source and digital platforms. Now, speed and consistency accelerates market entry, competitive edge. Consistency ensures uniform quality and stakeholder trust. Right. So, few more example. Let's see how AI is transforming market access and HUR by automating some of the complex tasks. Okay. So, Telius, AI analytical platform for pricing, access, and launch decision, info engine, text analytics to uncover disease and competitive insights, Access Infinity, AI and big data integration for market access strategy, Ficon, private AI models for economic modeling, Paraxel, ethical AI in pair negotiation and HTA. Okay, so all these companies are investing their time, energy, and money to be abreast with the AI to provide usability and, enriched user experience basically. Okay, now future, where it lies. Okay, future of AI lies in multi-agent ecosystems, basically to combine the entire enterprise into one. There are various departments in a lot of companies who do not talk to each other, or let's say a lot of files. People tell me that a particular file is stored in various departments in various cloud spaces, right, taking up a lot of cloud space. Same file is stored because every department stores it separately. Who gains in that? The cloud, the company which provides the cloud storage. Okay, so if these things can be automated, a lot of costs and space, cloud space saving can be done, can help in making the workflow better. If we introduce chatbots in many of the systems, people sometimes struggle in finding the HR policies. Okay, a chat, how many leaves are there? How many leaves can be reimbursed? Questions like this. right? Dynamic living models can be made, which can automate by taking the information from the large language models. And also precision medicine and outcome based contracting grows. AI agents will play a central role in market access and HUR, enhancing agility, evidence quality, and stakeholder engagement. Now there is something called as a digital twin. Now what is a digital twin? It is a virtual replica of something that exists. Okay. I have seen in certain conferences digital twin for type 2 diabetes, pan liver diseases, hepatitis B, C, D, liver cirrhosis, etc., where a kind of digital model is made, simulations are run, so that you get a fast track result of how a particular drug will react. Okay, right. So let's see a few example. Pfizer accelerates process scale up with digital twin. Pfizer uses digital twin technology to simulate lab experiments, speeding up innovation and reducing the need for physical trials, thereby accelerating manufacturing development. There's something called as in silico trials, which are coming up. Sanofi uses digital twins to simulate patient response in clinical trial, integrating biology and pharmacology data to enhance trial efficiency and personalized treatment. Siemens, now they are streamlining vaccine development. How? Siemens has demonstrated how digital twins can shorten development cycles and optimize vaccine production by simulating processes and facilities, help pharma companies achieve faster time to market and maintaining high quality standards. Illumina has employed digital twin technology to enhance emergency preparedness by simulating potential crisis scenario. They can strategize responses effectively, ensuring resilience and safety in operations. Future directions. Developing specialized LLMs for pharmacoeconomics, integrating it within the system, and ensuring responsible and ethical use of these large language models in healthcare. These are some of the interesting videos. So I know the information can be too much, can be overwhelming at time, but how we have learned by reading and watching videos. I have been going to a lot of conferences. That is how you learn these things, right? Okay, so with this, I think there are no major question. What is graph RAG? This I will put as an assignment question also. Do your research and give me the answer. Okay. Um, there was a lot of content for AI which we understand, but this needs to be taught. There is no other option. You will learn these things like pharmacoeconomics by practicing and reading again and again. Okay. Yeah. If there are no other questions, we can finish today's session, and you will get the assignments and the quiz shortly. Okay. Uh,
Okay,
Climate team,
ma'am.
we can. What do you want? You share the link of those videos. I'll pass it on to the climate team. They will share that with you. But they're very interesting. Do watch them. Okay. Yeah. So thank you, everyone. Have a wonderful evening. Go and eat now. Have dinner. Bye bye. Take care.
Wonderful.
Thank you, ma'am.
Thank
Thank you,
you. Bye
ma'am.
bye.
Thank
Bye
you,
bye.
ma'am.
Bye
Thank you,
bye.
ma'am.
Bye.